Counting permutations combinations for grade 12. First, we want to make revision on factorial notation. N is a non-zero natural number. Factorial of n is n times n minus 1 times n minus 2 times etc. 3 times 2 times 1. For example, 3 factorial equals 3 times 2 times 1, which is 6. 5 factorial equals 5 times 4 times 3 times 2 times 1, which is 120. Note that 0 factorial is 1 and 1 factorial is 1. N factorial is m times n minus 1 factorial. For example, 10 factorial equals 10 times 9 factorial, or we can write 10 factorial as 10 times 9 times 8 factorial, or 10 times 9 times 8 times 7 factorial. Example, simplify 20 factorial over 18 factorial. 20 factorial equals 20 times 19 times 18 times 17, etc. times 1, and as we said before, we can write 20 factorial as 20 times 19 times 18 factorial. Simplify 18 factorial by 18 factorial, we get 380. 15 factorial over 12 factorial. 15 factorial equals 15 times 14 times 13 times 12 factorial, cancelled by 12 factorial, we get 2730. N factorial over n minus 1 factorial. N factorial equals n times n minus 1 factorial over n minus 1 factorial equals to n. N plus 1 factorial over n minus 2 factorial equals n plus 1 times n minus 1 times n minus 2 factorial, cancelled by n minus 2 factorial, so we get n plus 1 times n minus 1. Activity. Given the set E equals ABC, n equals 3, which is the number of elements of set E. First, give all the permutations of two elements of E such that repetition is not allowed. Here we want to make revision. What do we mean by a permutation? A permutation is an arrangement of elements in a specific order. For example, the number of your phone, the password of your email, etc. These are permutations. We want to find the permutations of two elements of E. The first letter may be A, the second letter may be B or C. If the first letter is B, the second letter may be A or C. If the first letter is C, the second letter may be A or B. So we get 6 permutations: AB, AC, BA, BC, CA, CB. How to find the number of permutations? Yani how to find the number 6 without making listing? We put 2 boxes or 2 dashes. The first box may be A or B or C. So the first box has 3 possibilities. The second box has 2 possibilities because the letter that we choose, that we have chosen before, cannot be chosen because no repetition. We get 3 times 2, which is equal 6 permutations. How we know the number 6? In another way, by applying the rule, the number of permutations of R elements out of n such that repetition is not allowed is denoted by NPR, where NPR equals n factorial over n minus r factorial. In our example, n equals to 3 and r equals to 2, so we get 3p2, so 3 factorial over 3 minus 2 factorial, that is 6 permutations. Second, give all the permutations of E. What do we mean by all permutations of E? We means the permutation of 3 elements, that is all the elements of E, out of 3, such that repetition is not allowed. We get ABC, ACB, BAC, BCA, CAB, CBA. So we get 6 permutations. How we know the number of permutations in this case, that is the number 6? We put 3 boxes or 3 dashes. The first box may be A, B, or C, that is 3 possibilities, then 2 possibilities, then 1 possibility. So we get 3 times 2 times 1, that is 6 permutations. If we apply the rule, the number of permutations of E, that is the permutation of n elements of E out of n, is n factorial. In our example, n equals to 3, so we get 3 factorial, that is 6 permutations. Now, give the number of permutations of 2 elements of E such that repetition is allowed. There are 9 permutations, which are the previous permutations, and we add to them AA, BB, and CC. How to know this number, that is the number 9, without making listing? We put a box of 2 letters, 2 boxes. We put 2 boxes. The first letter may be A, B, or C, and the second letter may be A, B, or C, because we have repetition. So we get 3 times 3 equals 9 permutations. Another way we can apply the rule, the number of permutations of R elements out of n such that repetition is allowed, is n power R, that is 3 power 2 equals 9 permutations. What do we mean by a combination? A combination of R elements of E is any subset of E with R elements. For example, we have the set E, ABC as before, and n equals to 3, the number of elements of E. Give all the combinations of 2 elements of E. That is, give all the subsets of E with 2 elements. These subsets are AB, AC, and BC, so we have 3 combinations. So what is the difference between a combination and a permutation? In combination, the order is not considered, the order is not important. So AB and BA are considered only one combination, while in permutation the order is considered. So AB and BA are considered 2 different permutations. Look to this figure. If we are finding combinations, AB and BA are considered only one combination, and AC and CA are considered the same combination, and BC and CB are considered the same combination. So we have 3 combinations, AB, AC, and BC. For example, give all the permutations of 2 elements out of E, and give me the subset of 2 elements of E. We may have AB, AC, BC, BD, CD, and AD. So we have 6 combinations. Another example, give all the combinations of 3 elements out of E. We have ABC, or ABD, or ACD, or BCD. So we have 4 combinations. Now, How to know the number of combinations without finding all these combinations as we did before? We have a rule: the number of combinations of R elements out of n, which is denoted by C, by this symbol C, N, R. N is the total number of elements of E, and R the number of combinations that we are forming. C and R is equal to n factorial over R factorial n minus R factorial. So go back to the previous example. First, we list all these combinations and we get 6 combinations. If we want to find this number 6 without listing all these combinations, we apply the rule. We have n equals to 4, which is the number of elements of E, and R equals to 2 because we are finding the combinations of 2 elements. Apply the rule 4 factorial over 2 factorial times 4 minus 2 factorial, that is 6 combinations. Another example, if you want to find the combinations of 3 elements of E, we first, in the previous example, we listed all of these combinations and we get 4 combinations. Applying the rule, n equals to 4 and R equals to 3, because we are finding combinations of 3 elements, then we get 4 factorial over 3 times 4 minus 3 factorial, that is 4 combinations. For example, calculate C to 5. We have n equals to 5 and R equals to 2. Apply the rule 5 factorial over 2 factorial n minus R factorial, that is 5 minus 2 factorial, which is equals to 10. C68 equals 8 factorial over 6 factorial, 8 minus 6 factorial, which is equal to 28. You can use the calculator to find C68 using the calculator. First press 8, then shift, then the division, then 6, then equal. Example, we have 3 players A, B, and C. We want to form from these 3 players a team that consists of 2 members, doubles team, that is 2 members. Look here, if the team is formed of the player A and the player B, it is the same if we say that this team is formed of the player B and player A, because here the order is not important, while in forming the letters, in forming the words, if the word consists of A, B, it is different than the word BA. So in this example, the order is not important. Here the order is important. So here we use combination in this example, while here the order is important, so we use permutation. Okay? So in the first example, n equals to 3 and R equals to 2, we get C32, that is 3 teams. In the second example, we have 2 possibilities. If the words are not distinct, that is, we may have repetition, we get 3 times 3 equal 9 words. And if the words are distinct, that is no repetition, we get 3 times 2 equals 6 words. Now, each signal that a certain ship can make is comprised of 3 different flags hanging vertically in a particular order. يعني the arrangement of each color means a certain signal. For example, if we have yellow, green, red, blue, this signal may be don't approach to the beach or to the coast because there is a storm, etc., etc. Here, how many different signals can be formed? What do you think here? The order is important or not? The order is important because the arrangement of every four colors give me a certain meaning for this signal. So here the order is important. So we apply 4P3, that is 24 signal, or the first color may be yellow or green or blue or red. The second color has 3 possibilities. The third color has 2 possibilities. So we get 24 possible signals. Now we have 10 persons and we want to select a committee of 4 members. Note that in forming the committee, the order is not important, because if the committee, for example, contains Maryam, Reem, Rayyan, Warid, it is the same if it contains Warid, Rayyan, Reem, Maryam. The order is not important in forming the committee. So we use the combination C4, 10, 4 because we have 4 members in the committee, and 10 because the total number is 10. We get 210 committees. Suppose that we have a condition that Sami must be a member of this committee. So now we are choosing 3 out of 9. C11 means that to choose Sami, we have 1 possibility out of 1. Times here, we still have 3 members out of 9. So times C39, which is equal to 84 committees. We have 8 children. We want to make a group of 3 children. Here in the group, the order is not considered, so we use combination 8C3, that is 56 ways. Now we want to make a race. In the race, the order is important because we have rank 1, rank 2, rank 3. For example, if Sami is the first, Muhammad is the second, Tariq is the third, it is different than Muhammad is the first, Tariq is the second, and Sami is the third. So here the order is important, so we use the permutation 8p3, that is 336 ways. A student has to answer 80 questions out of 10 in an exam. Here, choosing the question, the order is not important. If we choose the first question or the second or the fifth or the seventh, etc., the order is not important, so we use combination C8 out of 10, that is 45 ways. Suppose that we must answer the first 3 questions. The first 3 questions are obligatory, so I must choose 5 out of 7. So we get C5, 7, that is 21 ways. Now we have 7 men and 5 women. In how many ways can a group of 5 persons be chosen? Here in forming a group, the order is not considered, so we use combination. And here in this part, we are not interested in the gender of the members of this group. So we are choosing 5 from 12. So we get C5 12, that is 792 ways. Part B, in how many ways can a group of 5 persons be chosen if the group consists of 5 men? So we are choosing only 5 men out of 7, so we get C5 7. Part C, in how many ways can a group of 5 persons be chosen if the group consists of 3 men and 2 women? Choosing the men, we have C3 out of 7 times, for the women we are choosing 2 out of 5 times C25, that is 350 ways. In how many ways can a group of 5 persons be chosen if the group consists of members of the same gender? So we must have only 5 men or 5 women. When we have or, we put plus. When we have and, we put times. So we have 5 men, C5 7, plus 5 women out of 5, so C5 5, that is 22 ways.